So our learning goal is I know and can use the triangle mid-segment theorem to find distances. That's what we're going to be working on. Okay, so we should know what a mid-segment is first. So we're going to start with that. A mid-segment is a segment that contains the midpoints of two sides of a triangle. So if you take a triangle, find two sides, find the midpoints, and connect them with a segment, that segment is the mid-segment. Let me show you on GeoGebra really quick. I'm just going to make me a triangle. And then to construct a mid-segment, I need to find the midpoints of two of the sides. I'm going to click on midpoint down here. It says click on 2 points or a segment. Click on that segment and that segment. And then the mid-segment is the segment that connects those two midpoints. So that DE right there is the mid-segment, right? D is the midpoint of AB. E is the midpoint of AC. Okay, there's a couple cool relationships that happened here, so I want to find those. The first thing I'm going to do is measure the length of the mid-segment. So we'll measure the length of DE, 3.5. And then I'm going to measure the length of the third side, the side BC out here. So if I measure the length of that, 6.9. I'm going to move that around a little bit. Sometimes because of rounding issues, it doesn't work like on GeoGebra here, it doesn't work perfectly. But what I should see is that this third side, 7.2, this side is 3.6. This side is always, the third side is always double what the mid-segment is. Again, on GeoGebra sometimes, just because of rounding issues, it won't show that, right? There's 5.1 and 10.2. The other thing we should see, and this one's a little harder to show on here, but you can kind of see it just by looking at it, is that DE right here is always parallel to BC. So if you look at the mid-segment DE is going to be half of the length of the third side, and it's going to be parallel to the third side. And we can construct all the mid-segments. I'll show you. If we construct the midpoint there, and then if I connect them all, so this is a mid-segment, EF. This is the third side that it goes with over here. Or I can construct DF, and it goes with this third side over here. Let's measure all of those segments, and then we can compare them all. So if I come down here, measure, we're going to measure that mid-segment. Whoops, that's not what I wanted. Let's see. Whoops. Down to measure. If we measure this one, if we measure this one, right, that's half of that. I can measure this one, and I can measure that one. Okay, but all the way across you ought to see, right, this one is half of that one. This one is half of that one, and this one is half of that one. So that brings us to what we're going to be talking today, and that is, pull that up here. That is the triangle mid-segment theorem, and it's pretty simple. All it says is if DE is the mid-segment of the triangle, then it will be half of the third side, half of AC. Also, the second part right here is that DE will be parallel to AC. So those are the two things you have to know. If you have a mid-segment, it has to be half of the third side, and it has to be parallel to the third side. Let's do a real quick little coordinate proof just to practice these. You can watch this. I'm probably going to find one of these to put on your assignment, so you can try one of these. It says, write a coordinate proof of the triangle mid-segment theorem. So it says, given that DE is the mid-segment of OBC. So we know, that's already told us here, right, that this segment DE is the mid-segment. So I need to show that it's half of the third side right there, and that it's parallel to the third side. So let's start with the parallel part. To prove this, I'm going to have to find, I need to find the coordinates of D and the coordinates of E. So if this is the mid-segment, E is the midpoint. So I'm going to use the midpoint formula to find the midpoint between B and C. So remember, we add the x's together. That'd be 2q plus 2p, and then I divide it by 2. And then I add the y's together. 2r plus 0 divided by 2. So I can divide both of those by 2. I'd end up with q plus p for the x-coordinate. 2r plus 0 is 2r divided by 2 is r. So this point right here is q plus p, comma, r. There's my x and my y. Okay, let's find the coordinates of D over here. So I take my two x's, I've got 0 and 2q, add them together and divide by 2. That'd be 2q divided by 2, which is just q. And then I add the y's together, 0 and 2r. So that'd be 2r divided by 2, which is just r. Okay, now I'm going to find the slope. Remember, to find slope, this is our slope formula. The slope is equal to, you subtract the y's on top, y2 minus y1, over, and you subtract the x's in the bottom. So let's do that. We want to find the slope of DE. So I'm going to go on top, I have y minus y, that'd be r minus r, over, and on the bottom I have q plus p minus q. When I simplify that, I get 0 over p, which is equal to 0. So the slope of this line right here is equal to 0. Okay, let's find the slope of the line on the down here. So again, go y minus y, that would be 0 minus 0 over 2p minus 0. I end up with 0 over 2p, which equals 0. So this one also has a slope of 0. So we're done with the first part anyway. We've proven that DE is parallel to OC. Okay, the second part is it wants me to show that DE is half of OC. This is a little bit trickier. To prove distances, or to prove something's half of another one, we're going to have to use the distance formula. So I'm just going to erase everything but those 2 points. So I know point D and point E. I need to find that distance. So I need to find out what the distance of DE is. And then I'll also have to find the distance of OC and compare those. Okay, distance formula. I'll put that up here. The distance formula, just as a reminder, is distance is equal to square root of, you take the x's, and it doesn't matter what order you go in, you just subtract the 2 x's and square it, plus, and you subtract the 2 y's and square it. And it doesn't matter what order you go in. So let's start with DE. I'm going to take the square root of, subtract my 2 x's, so I've got q plus p minus q, and square that. That's just x minus x, plus, subtract the 2 y's and square it. R minus r squared. So I end up with the square root of q minus q cancels out, so all I'm left with is a p squared, and r minus r is 0, so 0 squared 0. So I end up with the square root of p squared, which is just equal to p. That's the distance of DE. Okay, let's find the distance of OC. So subtract the x's, 2p minus 0 squared, plus 0 minus 0 squared. So I end up with the square root of 2p squared. Well, the square root and the square just cancel out, so this ends up being 2p. So what we can see right here, right, this distance was p, this distance was 2p. We've shown that DE is half of OC, right? P is half of 2p. So there's a coordinate proof. That's we just proved the triangle mid-segment theorem using that coordinate proof. Let's actually practice it though. We'll show you some examples here. We're going to skip past that. So this one says triangles are used for strength in roof structures, roof trusses. On the diagram, UV and VW are mid-segments. So come down here to our diagram. It's given to us that UV right there is a mid-segment. So U's a midpoint and V's a midpoint. And VW is also a mid-segment. That means that W is also a midpoint. It wants us to find out what is UV and RS. So I'm trying to find out how long this one is. Well, if that's a mid-segment, it's going to be half of the third side. So it's going to be half of RT. Well, if RT is 90, that means UV has to be 45. So that's our answer right there, is 45 inches. Okay, next we want to find VW. Let me outline it in a different color. VW, again, it tells us a mid-segment. It has to be half of the third side. So it has to be half of that side over there. let's see. Actually, it wants us to find RS, sorry. It wants me to find this long side over here. Well, I have VW, it's 57 inches. So because that's the third side that goes with that mid-segment, we had to just double it. So that'd be 114 inches. Okay, the second part says draw and name the third mid-segment, and then find the length of VS. So let's go ahead and do that. Let's draw the length of so the only mid-segment it didn't have drawn was this one right here, coming from this midpoint U to that midpoint W. So there's our third mid-segment, and it goes with that side over there. Hey, by the way, it says draw and name it. That mid-segment would be, we just name it this way, right? Segment UW, right there. It says find the length of VS when the length of the third mid-segment is 81. So we know this length over here is 81. This entire thing then, ST would have to be double that. So if I double that, the whole thing would have to be 162. But it only wants VS, so it only wants that part right there. So I take that and divide it by 2 because it's right. That's the midpoint. It's half. So it's back to 81. Okay. So that mid-segment's 81. Each of those two pieces is 81. The whole thing would be 162. So there's an example of how we can use the mid-segment to find other sides. Here's another one. It says in this kaleidoscope, AE is congruent to BE. So let's mark that. AE is congruent to BE. Hey, that's important because that means that point E right there is a midpoint. It also tells us that AD is congruent to CD. So AD is congruent to CD. That makes D also a midpoint. It wants me to show that CB, it has to be parallel to DE, what we're looking at there. So once you get to that point, right, if we know that DE is a mid-segment because those are both midpoints, that means it has to be parallel to the third side, right? That's a definition of a mid-segment is, or that is what our mid-segment theorem says, is that if it's a mid-segment, which we know that one is, it has to be parallel to the third side. The second part says if F is the midpoint of CB, so F is the midpoint of CB right there, that's given to us now. What do you know about DF? So let's see, DF right here, well, that means it has to be a mid-segment too, right? Which means it is half of AB, and it is parallel to AB also. Let's do this problem right here. So this one's a little bit different. Just slide this out of the way here. It says Pear Street intersects Cherry Street and Peach Street at their midpoints. So it's telling us right now, this is important, those are the midpoints. That makes Pear Street the mid-segment. So it's half of that third side down there. It says you leave your home and jog down Cherry Street. So we're going to leave our home and jog down Cherry Street to Plum Street, over Plum Street to Peach Street. Let's trace this in a different color here. So let's see, let's go again. You leave your home and jog down Cherry Street to Plum Street. So we go down here. Hey, let's figure out how long that is. We're trying to figure out the total distance traveled. That's 1.3. If this is the midpoint, that's also 1.3. So if you run down Cherry Street, you've traveled 2.6 miles. That's what we're measuring here. Then it says over Plum Street to Peach Street. So there's another 1.4 miles. Up Peach Street to Pear Street. So Peach Street to Pear Street. No, it's kind of, let me slide this over. It says that's 2.2, oh, the whole thing is, let me slide all this over. The whole thing is 2.25. Just adjust this so that's not left off the screen there. So the whole thing is 2.25, but you're only going up to Pear Street, so we're going to take half of 2.25. So 2.25 divided by 2, which comes out to be 1.125 Okay, so now we've gone there. So we've gone up to here. Okay, now it says over Pear Street to Cherry Street, so that distance right there. That distance is not given to us, but we know it goes with this third side. This third side is 1.4. If I divide that by 2, it's 0.7. So that distance is 0.7. And then back home up Cherry Street. So now I'm headed back up here. That's another 1.3. If I add all that up then, that ought to give me the total miles you jog. So really all they're doing there, right, is knowing if this is the midpoints right there and right there, okay, then we can figure out the distance of those whole things or those halves. And then we can figure out this distance of Pear Street because it's a mid-segment, which is half of the third side going that direction. Let's do this last problem. A mid-segment triangle has the side lengths, a mid-segment triangle has side lengths of 3, 4, and 5 inches. Sketch the original triangle. What it means by a mid-segment triangle, and hopefully you've kind of noted this, but if you have a triangle and you find all the midpoints and draw all the mid-segments, so I'll do it a different color. Let's do it in red. Right? This is a mid-segment triangle, this red triangle on the inside. If you take all the mid-segments of a triangle and draw them, you'll form another triangle. So this red one is what it's talking about. That is a mid-segment triangle, and it has the lengths of 3, 4, and 5. This is not drawn to scale, obviously. It wants to know what are the lengths of the original triangle. Well, if this is a mid-segment and it's 4, this side is 8. If this is 3, this side is 6. And if this is 5, then the third side is 10. These actually should have both been right triangles. If you guys remember 3, 4, 5, those are a Pythagorean triple. So is 6, 8, and 10. What you'll actually see then, and maybe some of you recognize this, is if I draw the mid-segment triangle, this triangle is actually similar to the original triangle up here. And the reason why is because you look at the scale factor, that's proportional, right? This triangle in red is each side is half of the big triangle. And that was one of the ways we proved similarity, is that with side, 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 right? If all 3 sides of one triangle are proportional or form the same ratio with all 3 sides of the other triangle. Interestingly enough, you could take all 3 of these and cut them all in half, find all the midpoints, right? And that triangle in green is also proportional to the triangle in red because each of its sides would be half of that. Right? So you can you could do that indefinitely, right? You could keep going out or in, and you keep getting the triangles bigger or smaller, but they'd all be proportional to each other as you draw these mid-segment triangles, which is kind of cool. Okay. I think this section most of you will enjoy. Like, it's not super tough. You're just going over these basic rules of mid-segments. And good luck.